So, hello. Today I will show you a tutorial about how you can shade a Houdini flame for Redshift with Substance Designer, and I hope this tutorial will show you how you can do that in a very fast way. The second part of the tutorial will be how you can denoise your rendered scene inside of Fusion or Natron with the neat video denoising tool. And yeah, maybe those tips will help you to achieve such things. And so here we start. This flame is the flame that I have showed last week. It's a very dense volume, a very dense simulation with a very thick cloud. This is frame 73, which I have already cached out. So when you download the file on Gumroad, you basically get this and some hints for that, how you can use this file or how you can use this in your workflow. And to shade those flames, especially when those simulations are very dense, you have to do some things to save some performance. So the first thing we do is we turn this to wireframe bounding box. So basically your GPU can save a lot of VRAM. Right now, when you already have showed something of this volume, you have a very high consumption of VRAM. So to get away with that, we save the file. Okay, let this open. We save the file, turn it also to manual, save. So we close Houdini completely. Wait a second, and now we see only 12%. So we reopen Houdini now. So, and now with Houdini open, we are at 21%. So we will open file. Nothing is loaded because we have set it to manual. So there's no update of the display or of the scenery. So we are already at wireframe bounding box. Let this be there and turn this to auto update. It's still loading. You see it. It's a very dense volume. So frame 73 had a volume or a data size of over 5 gigabytes. So this will take a while. So ready. The next thing is we turn right here into the shading network. And here we have our volume. And when you create a new volume, you basically got this. The emission ramp is just a grayscale gradient from black to 1. The black color at the left side is very important to be total black, because if you crank up the value maybe to this one, you get the entire volume box illuminated. So this has to be 0. Otherwise, your entire volume box will glow. That's not what we like. So on the right side, we can crank up the values like we want. So I will start a preview now with the current settings that you get in the file. So 20 gigabytes RAM. My swap is empty basically. Yeah, so I also reduced the render size of the image and reduced the amount of samples for this tutorial, just to it's basically a demonstration and testing of the shading, so we don't need a 4K rendering like what I've did in the preview. So I hope this will start soon. All those tiny density points needed to be translated, so here we go. So this is our corn flame. So, and it's very laggy, also because of the screen record, I guess. So what I did is basically, or what's important to get the correct shading of a flame is not only the correct shader or the correct color values, it's also highly dependent on your color correction later in compositing or when you render it out. So you have to consider all the impacts of your color grading at the end in your final shot, and you have to test it with the LUTs that you will use in your compositing at the end. So I have used my own LUT file, basically. That's a LUT I have bought in the past. Yeah, a lot, over 300, I guess. And yeah, when you don't have LUTs, basically, you can use also one of those which come with Redshift. So I prefer the ground control LUTs. So maybe Titan Cinelike Rec 7.9, which turns a bit more reddish. But that's not a problem. Maybe it's a bit realistic, I don't know. So, and I also chose and changed the photographic exposure. When you see reference photography, you have to keep in mind most journalists or photographers shoot with an f-stop value of 8. That's basically what you learn in every photography school or from every photographer. So f-stop 8 is the general value. The other value is the shutter time, which is basically how long the shutter has been open. So yeah, and the ISO, I think it's common knowledge. So basically we can turn this to 100, which is the minimum for most Canon cameras. And yeah, shutter time is important to get all the details. So the next thing we have to do is we want to get the shading from one of those flames into our current render. So when we connect this right now to this new flame, we will basically get this, just a grayscale illuminated thing. So that's not what we like. So how we can use those REMs with that reference photography in the render? There's a way, and this is called Substance Designer. This was really great help for me, and I will show you how you can do this now. So I will stop it rendering now, and I will turn straight to Substance Designer. I will open a new project, new substance. We don't need any presets. We only need a graph. And the first thing we need to do is to create a gradient. And there's only one gradient available for our task. That's gradient linear 1. And the next thing we need to do is to turn that by 90 degrees. So we have on the left side the black color and on the right side the white color. Exactly like in our shading ramp. So, and when we have this, we look for a flame. Right on Google Images, I typed oil fire, has very thick clouds, mostly completely in darkness or black, and also very bright flames, mostly reddish. So I chose this one. I will open this one right now. I guess it's a news article. Yeah, we don't want to advertise this, but we take this. So the next thing we need to make sure that this browser is in front of the screen all the time. So we have to keep that in the foreground. And then we switch back to Substance Designer. So now we can turn this a bit like this, maybe that. So, and now we need a gradient. And there's a nice tool, that's the gradient map. We add the gradient map, plug that into the gradient linear, and open the gradient editor on the right side. And here comes the magic. Here is a single button called Pick Gradient. And when I hit this button, Substance Designer will take a screenshot from the entire screen, and you can pick the colors from every object on the screen. So I will pick it right now. You see, screenshot is taken, and I see the color values. That's mostly white, or close to white. That's a bit brighter. So, and now we have to make sure the scanning works from the left to the right side, from the dark to the bright colors. So we have to start somewhere on the dark color and have to drag and drop the color or draw a line to the most brightest color. So we can do this basically, we can start here and drag and drop to the white. And that's it. So now we have this color spectrum. And the next thing we need to do is to create an output. And in that output, we add new item, RGB, and make sure you set to sRGB, because all images that you can find on Google, on the Google image search, is or are sRGB images. So this should be the same, otherwise, yeah, it's not correct. And I will take the half load. And then we need to save our project. So save everything. And color reference, I call this oil burn. Save. And then I will write it out to export outputs. So maybe we can rename this to oil burn 2 tutorial, and we call this where is it? We call it oil burn tutorial spectrum. So we also don't need a 4K map, so we only need a 128 pixels. I think that's highly enough, or maybe a bit more. So and save again, and then we write it out. Export output, yeah. Textures, color reference, bam, it's done. So now we can check it on the hard drive. So we will jump there and there, and here we have it. It's an EXR, 15 kilobytes, and that's it. So now we can close Substance Designer. We don't need this anymore, and we go to the new volume that we have and click on one of the colors, double click. Then we have an option right here above, and this is this option, show an image to pick colors from. So we can load another image there. This is my old one, and we can add a new file into this preview, and we take the oil burn 2, shows this, and we have it here. It looks a bit ugly, I guess this is because this preview can only show 8-bit colors, which should be changed from side effects to 16-bit, but that's not that bad. So, and now comes the tragic part in this entire workflow, because it would be nice when we would able to transfer this entire ramp directly to this ramp, but that's not possible. So what we need to do is basically this. We click here, we click there, and so on. We make some points. That's the first thing we do. Maybe those are enough, maybe too much. But to have more is not a problem, because those variations contribute a bit to realism. So it's important to have some points. The other way would to pick only 3 or 5 colors, which will also work. But to have it a bit more realistic, you add some variation to it. So the first color needs to be deep black. That's already known. And then we can move this quite near to this deep black value and pick our first color. So we click here at the color field, and then we have a color picker right here, and choose the most left color. And then we go to the next, double click, picker, and here. And so we can take some of those colors. It's a bit, it has to be something to do with eye judging, or you have to try to get the same distribution across this, which I was not able to do. So we will move this a bit there. I guess this is here. You also see that the colors don't really match the colors in this 8-bit representation. So this is only a representation. The value underneath is basically, I guess, the linear value. This is turned to linear. So that's why we don't get this true reddish colors, I guess. Oh, no. We have to pick more carefully. So and now we have another gap here. And another gap there. A bit yellow. And then we have white. So the next thing we do is we make sure that all of those values are interpolated. So I change this to B-spline for every point. So the values get mixed a bit better. Oh, B-spline, not Bezier. So, oh, no way to do this automatic. This is really sad. However, I hope it will look great now. So maybe this couldn't work. So maybe we can add a color here, another red color. Why is this? That's crazy. We really have to click this every time. I think that's a bug. So, that's not good. So, and here we have this very blue color. what's happened here? Oh, so I hope this is looking good now. Can move this a bit. Maybe we can add a color here. Something like that. Yeah. So okay. Now we save the file. Highly important. Save the file so that the color spectrum is saved. And then we will also crank up the density and scatter coefficients. Maybe to 40. I think that's not that dense. And the absorption coefficient to maybe 30 or 40. And we will test this. So we can also change the absorption colors, which would be realistic. And where is the flame? Why I don't see something? What was happening? So, my bad. We forgot to add the emission value, and the emission value is the heat channel. I don't recommend to use the temperature density, because the temperature density looks, in my opinion, unrealistic. So, yeah, I think heat that's what we have missed. So we have to keep that here. And now it should show something. I think I need a faster computer. Need more power. And here we have it. So it's fairly too dark. So what we do now is to crank up the density of the volume, and it will be brighter. Also this value, oh, a bit too much. Maybe 5. Maybe 2. 3. Maybe this. So, and now we only have the red color here. A bit brighter. And now we have to move. We have to move those values a bit to get the flame. Maybe we can delete this. We need to have the bright flame. So here we go. However, this will look differently depending on the color map that you input here. So you have to tweak this a bit, but you get a lot of variation from the image, and this is what makes it realistic, I guess. And then you can play with other features like the scatter coefficient. That's too big, I guess. 30. Oh, that's too dark. 50. 50 is a nice value, I guess, for those explosions. And then we have to check this. yeah, it's up to you what you use. It should look realistic. So, it looks also nice. Yeah. Here we have bright flames. And here, yeah, it looks awesome. I should have rendered this flame, I guess. Maybe. Yeah, this is how you can shade this. So when you finally have rendered out your scene to disk, make sure that you decide whether you want to burn in the LUT values or not. I have burned them in to the EXR, but that's not, in general, that's not the way to go, because those values will be applied in post-production. But in that case, I checked if this is working also with the denoise workflow. So keep also in mind to choose the right color output. I mostly work in linear space, so I use the out gamma 1. But that's up to you. And I also rendered this scene with the adaptive error threshold of 0.02, because that's a bit faster than 1. So the engine will not try to get rid of all noise. So those values are very low. However, we can get a very nice and clean result out of that. So don't save this. My bad. So, and then we use to open Natron. My Neat Video plugin, which I have bought a couple of years ago, is not able to work in the latest version of Fusion. So I have to open this in Natron. And here we can open the old render file, or my native render file. I guess this is this one. So this the original. No, that's not the original. That's the original render file. So I retimed the explosion inside of Houdini with the retime sub, volume sub inside of Houdini to stretch the 73 frames to almost 220 frames. I spared the first 5 frames because this is not working somehow in Houdini. It will calculate forever and nothing will happen. So we have basically 250 frames, 15 frames. And when we look at this, we see there's a lot of noise. A lot of noise in the render, also inside of the flame. And this is something we face almost every day. So how we can get rid of it? We need to have a tool called Neat Video. You can get Neat Video when you go to Google and you type Neat Video Denoise. And there's a website, neatvideo.com, and here you can get it. To get it working inside of Natron, you have to make sure that you buy and download the OFX host plugin. That means that's an OpenFX plugin that you can apply to Nuke, Fusion, Scratch, and whatnot, Natron. The other plugins are cheaper, but you can only use them in the specific application. So when you want to use it in Nuke or in Natron or Fusion, you have to use the OFX plugin, which is also available as a demo version. So you can test if it's working on your computer. Yeah, so there you can get it. That's the best denoising tool in the industry. That's my belief. So grab it, buy it. And yeah, this tool will save you hundreds of hours. And when you save render time, you also increase the lifetime of your entire system, of your computer, because why you want to sample volumes to the tiniest bit that no one can see or recognize. So yeah, that's the way to go. You have to pick a frame in between where you expect a lot of noise. So maybe this one could be nice. Here's a lot of noise. And then I hit prepare noise profile. Now the computer is calculating. The frame is open. And now there are two ways to do this. You can click auto profile, which will pick somewhere on the screen a pattern where you can have ultra low noise. When the ramp is red, you have a direct hit to the right amount of noise. This is a very good pick right now. You also can see the color variation here, and you can hit auto fine tune. And then we can watch how good this can look. So, and as we can see, it doesn't look nice. So to pick the auto value isn't the way to go. So all the noise here is still there. So what we do now, we go and grab a area with the hand. And when you do this, you have to make sure that all 4 areas look basically equal. So means they have to look flat. If you maybe would pick something here, the engine would recognize those areas as noise, which is not what we want. This will basically get blurred out, and this is not what we want. So we pick an area which looks equal on all screens and grab something here. So it will have a lower quality maybe, but I guess this is not important. So we turn this auto fine tune and we hit this. And now most of the noise is gone. We also can check if there's a major difference or blurring happened in the denoising process. And maybe a bit of blurring is happening, but I'm really not sure if this is truly the case, because this is it only reduces the noise, so it might look a bit smoothed out, but I guess this is not that important, especially on 4K. The difference is the denoised version looks a lot better. So when we have this, we can hit apply and render this stuff out. When you have rendered this sequence, make sure that you output the ACES color profile, ACES CG, or the profile you want, it's up to you. I work in ACES CG, so then you can close this application and open Fusion. I use the latest build of Fusion, which is the version 16, which has a large amount of bugs right now, but it's a lot faster than Fusion 9. So definitely check this out. So I have already made something here. And yeah, This is the denoised version that I got. There are white sparkles that we can reduce in Fusion. Yeah, this is the denoised version of my explosion. And the next thing what I did was to change the primary colors a bit with the OCOI CDL tool, Candela tools, so that the image will look a bit more flat. So to get rid of the high contrast. This is highly important when you use optical flow after that, because optical flow will look for the pixel movement, and with optical flow you will be able to retime your shot or to apply motion blur. And what I did is I retimed in 2 stages the speed of the entire simulation optically. So from 220 frames I moved up to 384. I cached this out too. And what I highly recommend when you use some very noisy footage, we can maybe copy this here. You can also get rid of those sparkles with the smooth motion. But this tool is also, the optical flow tools are only available in the studio bundle of Fusion. So purge cache, we don't need that. Why is Fusion caching this out? I don't want to have this. That's a nice bug. Okay, I don't want to wait. Close this. And here again. So when you have a sequence which is very noisy and has some sparkles here, you can use the optical flow and the smooth motion tools to get rid of this. Also errors in the image, black pixels or something like that. You only have to keep in mind that the image can get blurred by the smooth motion tool. But that's not a problem, because since 2 years, I guess, I sell a plugin, a macro plugin for Fusion, which basically is a sharpen tool, similar to the sharpening tool in Nuke, where you can choose the influence channel, maybe the saturation, luminance, or other values. And here you can, this is basically the difference. So this is this, and this is that. It's a very big difference. You can also use this on every render image. It works best on log images, maybe photography. I use it a lot when I do image photography or model shootings. So this will help you a lot to sharpen your post-sharpen your image without getting those rings. When I would use the native sharpen tool in Nuke or in Fusion, you get those rings. So my macro is basically doing that. So you don't get those rings, and you have a slider to minimize this effect. Yeah. And yeah, I color corrected. Oh, that was a bit too much. However, and yeah, I added some film grain at the end so that we can get back some arrows but it's highly important when you try to retime your shots to really get rid of all the noise you can get rid of, because noise can distract the optical flow calculation. I also changed a lot of the values. However, I retimed the shot. I have done this on the rotation 2, in the turntable. Yeah, that's the difference. Doesn't it look nice? This is the original denoised render, and this is the sharpened version. It looks more natural. Yeah. Some tiny stuff here. Wow. So, some tint and noise back on the frame. So, yeah, that's it. I hope you have learned something in this tutorial. When you have questions, write a comment in the comment box. And when you like to have the flame asset with all that stuff, you only need to open Gumroad. So, and on Gumroad, you can basically get the fireball. You can download it. Right now, it has a discount to 3rd of June of 50%. And yeah, go to my page if you like, and you can see it here. Oh, nice, a new rating. So yeah, that's it. I hope you have fun with that tutorial, and I hope it's not too boring in some situations when the render time is cranking up. So yeah, bye.